Hi, my name is Seo Jingwen, metric number 2510934995. We're with my buddy Chong Ken Chen from Group 7 to present about the Lab 2 operational amplifier using LP space.
The objective of this lab is to understand the basic characteristic of operational amplifier circuit configuration, and the second is to compare the theoretical and experimental simulation value in each configuration. And the last is to determine the effect of capacitor, bypass resistor, and internal operational amplifier offset voltage to the output voltage.
In the experiment, we have conducted 5 types of operational amplifier. The first is inverting amplifier, following by non-inverting amplifier, integrator op-amp, differentiator op-amp, and lastly is summing amplifier. In this presentation, I will present about the integrator op-amp and differentiator op-amp, and my buddy will present about the inverting amplifier, non-inverting amplifier, and summing amplifier. Now I pass to my buddy to present about the inverting amplifier.
Hi everyone, my name is Chong Ken Chen. Today I want to present inverting amplifier. First, we can see this circuit, the input is connected to the inverting terminal V- and the non-inverting terminal is ground. And R1 is 1k ohms and R2 is 33k ohm, and the input voltage source is VU sine. And this is the waveform result for our inverting amplifier. This case, the output to be inversed by 180 degree. We calculate the value of AV is negative 33 and the experiment value for AV is negative 13.96. These two values have some gap because the supply voltage limits for the output is clipped. For question 1, why the output waveform has been clipped? This is because output voltage beyond the supply limit and saturation. For question 2, why this called an inverting amplifier? This is because output waveform upside down of the input. Input signal connect to V- and V+ connect to ground. The second is non-inverting amplifier. The difference of inverting amplifier is the input is connect to the non-inverting terminal V+ and VU sine. We can see we have R1 1k ohms and R2 10k ohms. And this is the waveform result for our non-inverting amplifier. This case, the output remain in the same phase as the input. And the theory gain AV is 11 and the experiment AV we get 10.98. So these two result is almost same. First question for non-inverting amplifier. Why is it called non-inverting amplifier? This is because output waveform is same phase as input. Second, input signal connect to V+. V- connect to ground. And question 2. What does non-inverting mean if a sine wave connected to the operation amplifier plus terminal? The answer is output stays same phase as input. Size of output signal is larger depending on the gain.
Next is about integrator op-amp. This is the circuit we conduct in the LT space with the R2 value is 100k ohm and the input voltage source we using the pulse. And in this circuit, we are adding the feedback resistor with 10 mega ohm and it connected at the feedback loop. This is the output waveform for V in and V out. For V in, there is the square wave, and for V out is triangular wave. And for calculated, V out we get the value is negative 1 volt, and for experiment, V out we get the negative 0.967 volt, which is very closer to the calculated value. For the question 1, note that the 10 mega ohm resistor, a very large value, is not in the ideal integrator circuit. Why it is there for? The 10 mega ohm resistor is the feedback resistor that provides a DC feedback pulse and it preventing op-amp from saturating and also stable the circuit. And for question 2, it is discussed what should happen if a small DC component was present in the input waveform. It will happen for the output will be drive or ramp down or up continuously when the small DC component was present in the input waveform. When is differentiator op-amp? In the circuit, we using R1 for 1k ohm and here got a capacitor with 0.01 microF, and for the input voltage source we using the pulse, and here we adding another capacitor for 100 PF. This is the output waveform for V in and V out. For V in, the waveform is like triangular wave, and for V out is like square wave. For the calculated value, we get the V out is equal to negative 1 volt, and for the experiment, we get the V out is equal to negative 1.98 volt. Give a difference between the calculated value. For the question 1, Note here that the 100 pF capacitor, a very small value, is not in the ideal amplifier. Why do you think it is that? Think about the derivative of a square wave, for example. Okay, so for answer 1, the 100 pF capacitor is present to prevent the high frequency noise and oscillation because it will cause the circuit become unstable. And you can see here, the Vout with the 100 pF capacitor, the waveform is like not high frequency noise, but you see without the 100 pF capacitor, you have the high frequency noise compared to the 100 pF capacitor. Next is question 2. What will happen to the output waveform if the input Vin is increased to maximum value? Briefly discuss this in your report. The operational amplifier will become saturated and it will clipping output waveform if the Vin is set to the maximum value. And you can see here, this is the Vout with the Vin equal to 1 watt, and here is the Vout with the Vin maximum value, and I set to 15 watt, and you can see the output will become clean.
This is the swimming amplifier circuit, so we can look at this circuit. We know multiple input signals are fed into the inverting terminal, and the op-amps sum them into one output signal. And the input voltage source we use sine. Also, we can see R1 is 10k ohm, R2 is 2k ohm, and RF same with R3 is 10k ohms. And this is the waveform result for our swimming amplifier. In this case, the output is to be inverted by 180 degree. And we calculate the Vout is negative 6 watt, and the experiment result Vout is negative 5.99 watt. So the Vout is almost same. First question for swimming amplifier. What do you understand about swimming amplifier? I understand about swimming amplifier is combine multiple input signal into single output. For second question, explain what happened to the output if the frequency of the source is increased to 3k Hz. It will happen, output decrease and distorted.
In conclusion, they have the 5 op-amp circuit, inverting, non-inverting, integrated, differentiated, and summing amplifier with successful demonstration in this lab too. And simulation result match theoretical value with minor difference due to non-ideal op-amp limit, which is gain, bandwidth, and also clipping. The practical component, feedback resistor, and small capacitor are important for stability and noise reducing. And for Altispace, provide to be an effective tool for analyze both ideal and real op-amp behavior. So that's all for us. Thank you.